Well, hello and welcome to part two of the recording. In part two, we're going to talk about save the running configuration. By default, in the Cisco routers and switches, if you spend a great deal of time configuring and assigning all the command and doing everything you need to do, but if you did not and you forget to save your configuration by running this command right here, copy running -config to startup to startup config. So what happened that all your command are in what we call running -config. So they're startup config, that they have not been copied yet. It was Cisco called an NVRAM. So the whole time your configuration installed on RAM, and what happened to RAM? RAM is known as a volatile. However, Cisco have another type of RAM known as NVRAM, or non-volatile RAM. So if you don't copy what was running in RAM into an NVRAM, as soon as you turn off that device, all your configuration will be lost and deleted and will not be saved. Now, how do we save configuration? You save configuration once you're done with all your work by typing the following command: copy running -config to startup -config. If you do this, whatever configuration in RAM will permanently be copied in the NVRAM. I repeat, if you forget that and you reboot your system, you will lose everything that you were working on. All right, another very important aspect when we configure Cisco router and Cisco switches is assigning IP address. Well, it happened to be that assigning an IP address for a Cisco router is not a big deal, because every single interface in the Cisco router is a program to get an IP address. If your Cisco router has four interfaces, 4 NIC card, all those 4 NIC card can get an IP addresses. But if your switch has a 24 or 48 port, they're not configured, they're not programmed to get an IP address. Well, that creates a problem, that introduces a challenge. What if you want to configure using out of band, you're in band, you want to configure the Cisco device that's really way far from you? You have no other way of doing that unless you assign it an IP address. And there is a way that Cisco had embedded into all Cisco switches. So you would add what we call a virtual IP address known as SVI, Switch Virtual Interface, SVI. And we're going to go and talk about that. All right. So the first thing they wanted to know, before we go into the switch, well, how you assign an IP address to your computer devices. Well, those who, if you ever had to do it, you know well that Windows, for instance, has 2 ways of obtaining an IP address. By the way, what is an IP address? IP address is a number that we assign to an operating system, to a network operating system, in order to identify that an operating system is in a network. And no two devices can really have the same operating system. In this case, no 2 devices can have the same operating systems. What you have here is subnet mask, and here is the default gateway. So every single device or Windows operating system, if you want, that need to access the network and the internet, and need to access the internet, also need to have this minimum requirement: an IP address, a subnet mask, and also a default gateway, in addition to DNS over here. But we'll talk about the DNS another day. Cisco switches, however, Cisco router, like I said, there is no problem. Cisco switches, however, you can't really do that. You cannot assign an IP to an interface because the physical interface in the Cisco are not programmed to get an IP address. A way around that, or a solution to that, is you assign an IP address to something that Cisco known as SVI, because some Cisco switches are layer 2, and a layer 2 do not support an IP addresses for all the interfaces. Now, if you have a layer 3 switch, you will have no problem, because layer 3 switches are very similar to routers, so they can get an IP addresses. But layer 2 that work at a data link of the OSI model you need to configure an SVI, which is a virtual interface, before you assign it an IP address. As you can see here, each switch has a default VLAN assigned to an SVI, and we're gonna do a command. We're gonna do a demo later. Again, coming back to a window, this is a Windows and operating system, and you can see what assigning static IP addresses. But if you want this window to get an automatic IP addresses, you just click here. When you do this, an Windows operating system or a Linux or a Mac in this case will get an IP address from a device known as a DHCP, which stands for Dynamic Host Configuration Protocol. What is DHCP? Is a service or a server that signs TCP/IP settings automatically to help you, because if you have 200 computers, you're not going to remember all this number. It's really difficult. So you have to automate the process. So there is something known as a DHCP that automate this process for you. But all right. So here you can see that this device is getting an IP address automatically from a DHCP. All right. Now moving to a Cisco switch. For Cisco switches, if you want a switch to get an IP address, first we have to create what we call an SVI. You have to create an SVI, and once you create the SVI, that you assign it an IP address that you want. You can assign it the IP address, and you can assign it a subnet mask. And there's really if you want, we're the command that will do no shutdown. Why we do no shutdown? Each time in Cisco devices, when we assign an IP address and interface, we type this command known as no shutdown. You are telling the device, you are telling the Cisco router or device to not shut down, to keep this interface up all the time. If you forget to do no shutdown, what's going to happen? This interface will go down and you will not be able to see it and you will not be able to access it. So I'm asking you to not forget to type no shutdown when you're configuring interfaces. Otherwise, although you assign an IP address, when you try to connect or access it, you will not be able to. All right. If you want to see all the interfaces in the Cisco router and switches, if you want to see all the IP addresses, if any IP address is up or down, or if it has been configured or not configured, this well-known command known as show IP interface brief. It shows you all the interfaces that the device has, and it shows you if they're up or down, and it shows you if they have been configured or not configured. All right. If you want to test connectivity between what we call end-to-end devices connectivity, maybe between a switch and a computer or workstation, or between two workstations or two switches or two routers, the famous command, the well-known documented command that we use is something known as a ping. And you go and type ping space and the IP address of the device that you want to ping. All right. And here there's a little demo that we're going to do together. I'm going to walk you through the process. Similar, because you guys will be assigned this. This will be your assignment for this week. But I'm going to create a demo where I'm going to go to a similar environment or similar lab that kind of will help you configure, help you finish your lab packet tracer labs. All right. So what did we want over quickly? In this chapter, which is chapter 2, configuring a network operating system, we'll learn about the Cisco operating system. We'll learn about the Cisco operating system privilege mode. We talk about some new commands that's enable, disable, show. We talk about the host name. We talk about config T. We talk about the ping command. We talk about assigning IP addresses, subnet mask, and we talk about testing connectivity. In part 3 of this chapter, I will go over a demo and a lab, but I hope if you have time, you can follow me so you learn how to configure your device properly. All right, so what is your assignment for this week? Your assignment for this week is to read chapter 2 at the online. I want you to understand that there's an e-version book of what we call it online when you go into your classroom. When you go to NetAcad, there's an e-version right there. Next, you want to complete chapter 2 exam. As you know, every chapter we do has an exam that you need to complete it. And finally, you need to complete 2-3-4 packet tracer configuring initial switch set lab, which I'm going to assign you this week. That's all for this for part 2. Now I want to move on to part 3, where I will go over the process of configuring a